All right, problem one. We're giving these points and we got to try and find the equation that fits it best. Now, when I'm looking at this, the ones we're dealing with exponential growth, logarithms, and then exponential decay. This is not decaying. The numbers, as x goes up, the y is also going up. It's not decaying. It's not losing and getting smaller and smaller and smaller. It's growing. So we know it's either exponential growth or logarithmic. At the very beginning, this grows by zero point 0.5. Then from here to here, zero point 0.4. And then here to here. Now it's starting to go up a little bit more, a little bit more. So it's almost a constant growth, which I don't like. But again, as the numbers get bigger, it looks like, hey, they're starting to get wider and wider apart. That would represent a graph where it's not a whole lot at the beginning, but boom, in the end, it's going to exponential growth. So our equation there will be something of the form y equals a times beta some power. We've got to find this a and b value. That's what we're trying to do. So we're going to go to Desmos, plot these points, and figure it out. So if I go to Desmos, here's Desmos. How do I put a table in? Well, I'm going to hit this plus sign, then I'm going to hit the word table, and it's going to bring up a table. Now, I've already done it here. I've already entered the table, and you can see our points here. I don't know where this, how this 12.2 is on here because I'm not showing. Oh, there's how we did it because we have the wrong thing. This should be a 1. That would have really messed things up, wouldn't it have? So there, much better. There's our data, a little bit cleaner. It almost does look like a straight line, but I know it's not because that's not what we're studying right now. So what I now need to do is I need to tell it, hey, I want you to look at these points and give me the equation that best fits them. So I'm going to first grab this guy and move him out of my way. Now I'm going to enter y, and I need to enter sub 1 to tell it to look at my data. So I hit the 1. Notice it now says, oh, 5-element list. We're going to look at your list of points that you have plotted here. So we then need to get our little tilde, which is hidden under here. A lot of hiding going on today. And I then need to go ahead and say A times B. So I hit A, and I can put times B, or I can just go ahead and hit B. It'll be fine. And I want to raise it to the X. I'm going to go ahead and I'm going to go back here, and I want to raise it to, so I'm going to say, hey, raise me to X, but I need to say sub 1. If you forget sub 1, it's not going to work. Sub 1. Now it's going to give me all the information I need. It's going to say, hey, this correlation of determination, 0.99, pretty stinking close. It's almost a perfect fit. Look at our green line here. Here's the line of best fit, and it's hitting our points almost perfectly, isn't it? So our data is pretty much following this. So our A is going to be a 2 point. We're just going to round, going to cheat a little bit here. 2.1 and a 1.2. A 2.1. So Y is approximately 2.1. And we said B. We look back here. B was a 1.19. We could use, we'll just use 1.2 to the X. That equation best describes our data. Now, if we want to be super accurate, we would use every single digit there, but we're not. We're just going to give that as our answer here to this problem.